this is a very beautiful diagram, right? So the diagram here is what a trapezium. So we don't care what is inside, but sometimes along the road we know how to use this information to answer the questions that they are asking. The question here says that you should calculate correct to the nearest squared centimeters, right? So meaning that all the measurements are in centimeters, the area of the remaining region, or maybe the remaining portion. That's what the question is. I said for sure this part, right? You see that all the other parts has been shaded, right? So all the other parts of the trapezium has been shaded except this one. So you want to determine the area of this trapezium. Now the key here is that if you want to find the area, especially concerning anything that has to do with what a shaded region, you must focus on the shapes that are involved, right? So here you can see that the whole thing is a trapezium, so you have somewhere the semicircle within as well as some triangle inside. Now here's the scenario. Let's say you are at what, a coffee shop, right? So being at a coffee shop here, so this is a coffee shop. You ordered for what, a coffee, right? So this is my cup, maybe that is a beautiful cup, of course. So this is a cup, a coffee cup, and then you ordered a cup. You know that the level of or maybe the highest or the measurement of this cup here, that should be somewhere, it can take like, let's say 15 liters by an assumption, right? So just a 15 liters. So you order for a coffee that can maybe at the maximum of would that be 12? That should be 12 liters, right? So 12 liters by just an assumption. So what happens here, this is just a very clear definition that the remaining part here at the top here is going to be 3 liters. Is that okay? That is very simple to understand, right? So you can see the picture there. Okay, perfect. So bringing that idea to the way of solving a shaded portion question, so specifically dealing with this trapezium here, is that what happens if you consider our trapezium to be the whole cup here, right? So the cup here, and then things that are inside, so this portion here, which is the coffee, to be the shaded portion in this case, and then so the remaining part is going to be the unshaded part here. Okay, now with that in mind, so you need to know the measurements of the whole trapezium. That is should be your starting point. So once you know the measurement of the whole trapezium, and then you know the portion that has been shaded, then that should be very easy to determine what remains, right? So on the other way around, what will happen if you know this portion here? So bringing that idea to the coffee shop here, so you can see that if you are told that what remains here is just for 3 liters here, then obviously you should know that you are taking like 12 liters out of the 15. That is somehow straightforward. Is that okay? Okay, that is just to understanding on how to tackle questions related to shaded portion. Now let's have a look at the whole question here. So from the question, we were told that the whole diagram here is a trapezium. That is the M, N, O, and then T, right? So everything here is a trapezium. In which this MN, so this MN here is parallel to SR, right? So it's parallel to SR, maybe that should be parallel to TO. Is that okay? So you know the meaning of the parallel, so they will never meet, right? So you must know all the information is given to you in order to know how you can easily tag the questions. So with all this information, maybe you may pause the video, read the questions very carefully, and then let's start solving the problem here. So now that we know our target, so our target here is to know the area of the whole trapezium here. So once you have the trapezium and then you know the portion that has been shaded or non-shaded, we can easily subtract the two, right? So here the target here is to know the entire trapezium. That's the first part. And then if you know the area that remains here, right, because this may be a little bit difficult to calculate because we don't know the exact shape that has been shaded here, right? So that is somehow difficult to get it. But if you can easily identify the area that remains, then if you subtract this area from the whole trapezium, we can easily tell that this is the part that has been shaded. Now the question says that this is also a semicircle, which is somehow we know the definitions of a semicircle, right? So that is why all the information is given to you are very important. Now, what will be the starting point? Now, our aim here is to find the area of the trapezium, the whole trapezium, right? So that is our aim here. So the area of a trapezium, right? So trapezium. Okay, so that's the area. So you must know the definitions of the trapezium, the area of the trapezium. That says that 1 on 2, so 1 on 2 multiplied by the height, and then multiply by what? That should be the small base. Let me use, sometimes use b plus the small b. Oh, some people use a and b and so on and so forth, right? What matters here that you must understand what you are doing. So this is the area. So the area is 1 on 2 multiplied by the height. So that's the height, and then multiply by the big base, and then plus the small base. Is that okay? So I'm using these letters to represent that, or maybe you can write it in full. So which one is the big base according to the diagram here? So according to our diagram here, from here t to the x here is going to be our big base, and then the small base is going to be the m and the n, right? So from here to here is our small base, and then t to what? To the o is going to be what? Our big base. So you can easily change this thing to be 1 on 2 multiplied by this thing, and then the big base is t to o, and then plus what? M to n. So this is our target here. So now we want to determine the whole area, and then we find, secondly, we find the area of the semicircle. We subtract the 2, then work down, right? Okay, now do you know the t to, so what is missing? That is the point here. So in the definition, anytime you have the definition, you must make sure that everybody, all the players, all the first 11 are available. So what I mean by the first 11 here is that you must make sure that you have all the figures to the corresponding letters in your definition. So this is what we have. This is just a number. 1 on 2 is a number. The h here is the height. So we don't know the h. We don't know the values of the h here. Is that okay? So we don't know the values of the h. So for sure, this h and this h are the same. Is that okay? That's why you have the 8 centimeters, 8 centimeters. So the heights are the same here. And then we also don't know the measurements of the t to o. So that's the big base from t to o. You must also find that measurement. So what about the m to n? You also, so okay. So that is good. We have the m to n to be 40 centimeters. So that is the only thing that we have here, right? So 14 centimeters. So we need to find this as well as the h and the what, and the 1 on 2. Is that okay? So 2 things are missing here, so we need to find this and then that guy. So on the information, so all the information that we are giving, so that's all that we are going to use to determine the missing what variable, right? So we have here to be 60 degrees, and then here to be h, right? And then we also have here to be 12 centimeters, and then here is also to be h. So how can we determine the h here? So to determine the age, before we determine the age, if you are new here, why don't you subscribe to the channel if you are gaining some value from this video. If you're already here, make sure that you give us a thumbs up, subscribe to the our channel if you are new, or comment down below if you have any questions that you want us to help you along. Okay, now with this, I know that here is for 60 degrees here, and then you also have 12 centimeters. So you should bring up all the definitions that we know corresponding to what a triangle. For sure, this is what a rectangle triangle. So almost all the definitions that you know about a triangle, just write them down. So after writing them down, you ask yourself which one will be applicable, which one can you use based on the information given to you, right? So all the information that we have, you have here just to be 60 degrees. We don't know this guy, that's just 8 centimeters. So finding the values of these 8 centimeters, so you can say that from triangle, is that okay? From this triangle, you must make sure that you stay the triangle, because there are 2 different triangles here. So from triangle, that should be, someone can go for TMS, right? So maybe another person can go for MST, or maybe STM. Is that okay? Just make sure that you stay the triangle that you are going to use. So from triangle TMS, then what are we going to use here? Let's bring down to the idea called a SOHCAHTOA. So I know that you've already you are familiar with something like this. So SOHCAHTOA, right? So SOHCAHTOA, that is what sine is your sine theta. That is going to be opposite over hypotenuse, and then the car here, that is what adjacent over hypotenuse, and then finally give me the values of this thing in the here in the comment section below. Okay, using that, with that in mind, so we can say that sine theta, right? So that is what you are going to use. So sine theta, that is going to be SOHCAHTOA, that is opposite of over what? Adjacent. Oh, that is going to be opposite of our hypotenuse, right? Right? So yeah, that is opposite of our hypotenuse. So do you have the opposite here? You have the opposite to be your h. What about the hypotenuse here? Remember, one thing about your trapezium is that if here this side and this side are almost the same, so here is going to be 12 centimeters because we have one side, right? The reason why we are not using this triangle is that we are not giving any angle at this portion. Is that okay? But here we are giving an angle, and then we also know that the length from here to this part is almost the same as well the length from here to this part, right? So we have two people available. You can easily determine the third part. Is that okay? Okay, so perfect. So we have that sine of 60 degrees, that is the SOHCAHTOA. Sine of the theta, that's because opposite. So if you are here, the opposite will be the h, so that's going to be the h on what the hypotenuse, that is 12 centimeters. Is that okay? So finding the values of the h here, it means that we are going to multiply this 12 by this. That's going to be 12 sine of 60 degrees, that is going to be equal to the h. Okay, so what do you think the values of the h is going to be in this portion? So according to my calculation, I have 10.39 centimeters. If you are having different answer, make sure that you just comment along how did I get this particular value, and I'll explain that in the comment section below. Okay, now that we have our h, so this is our guideline. So this is what we are looking for. Now that we have the h to be what, that should be, so multiply by the point here means multiplication, right? So 10.39. Is that okay? So you have 1 on 2 multiplied by 10.3, which is the height here. What about the TO? Now our target here is to find the length from T to the O. But remember, here we are giving this portion here to be 14 centimeters. That tells me that the S to the R here is also 14 centimeters. So we need to find here and then here, and then we are free to go. So that is what the T to the S, and then what the R to the O. Is that okay? So with the properties of the trapezium here, we can say that if this is the length, that's the straight line from here to here, whatever will be here must be the same measurements that will be at this portion. Is that okay? Okay, that is a very clear understanding there. So here, how do you determine the values of one side? So with our SOHCAHTOA here, I can easily write this guy. Make sure that you are not just watching the video, then have some pencil and a pen down, and then at certain point pause the video and then write it. Or you may always go back and go and check the solution. Okay, still from this triangle. So from triangle, you know that this is another symbol of a triangle, right? So for triangle TSM, right? So this same triangle here, because of we are giving one angle, that is why we are still here. Is that okay? So should in case you have this side here, you can also use that. Maybe sometimes you may be giving the h but without giving here. So what are you going to use there? That is where you have to apply the Pythagoras theorem. So that is just for another video here. But here what you have is what you are using. Is that okay? So now here is 60 degrees. So now we can say that how can we determine the value here? This is what we are looking for. So once we have this guy here, we can proceed. We know here to be what, that's the 10.39. Is that okay? So can we use the properties that we have here? Someone can use the Pythagoras theorem, which is accepted. Is that because we know here to be 12 centimeters, and we also know here to be 10.39. Is that okay? So determine here will be very easy. If you know how to use the Pythagoras theorem, that is the hypotenuse square is equal to the adjacent square plus what, the opposite squared. Is that okay? So by here I'm going to use the SOHCAHTOA. So because I have the angle here, so from the car here, that's the cos theta. So the theta is 60 degrees, right? So 60 degrees, that is going to be cos, that is equal to the adjacent of our hypotenuse. Always where you are, the down here is going to be your adjacent, right? So the down here, which we don't know here, that's the tx, from here to ts, or maybe you may use the letters to represent that. But I always advise you to use the letters available to you, right? So the letters available here is t to the s here, and then here we are divided by what, remember the car is here, that's it, adjacent of our hypotenuse. So yeah, what is the hypotenuse of that? Is 12 squared. This is just the similar to the one that we solved already. So that's going to be 12 multiplied by the cos of 60 degrees is going to be the ts. So what do you think is the values of this ts? So here I'm having what 6 centimeters. Is that okay? So if you have a different answer or you don't know how to punch this thing on the calculator, make sure that you once again comment along. Don't forget to subscribe to our channel if you are new here. Give us a like and share the video to your friends to enjoy more content like this. Okay, we have here to be 6 centimeters, right? So here is 6 centimeters. So as I said earlier on, here is also going to be 6 centimeters. Is that okay? By the properties of the trapezium, right? So if here is 6 centimeters, here is 6 centimeters. We already know that this side here at the top here is what 14, right? So 14 centimeters. So meaning that this here is also a 14 centimeters. So 6 plus 14 plus what another 6 here is going to give us the whole length from T to the O here. Does it make sense? So that's going to be what 6. Let's take this Sokato away here. So this Sokato away, that is going to be 6 plus what 1 4 and then plus what 1 4. That should be equal to 26, right? So 26 centimeters. Is that okay? Meaning that the whole from T to O here is going to be 26 centimeters. So we are there, right? So we are there. Our work is almost done, right? So the rest is just a simple calculation for us to determine what the area of pause the video and give me the area of this thing in the comment section before we proceed. So here I have the area of the trapezium to be 207.8 centimeters or maybe square centimeter, right? So this is the area of the trapezium. So fine, almost 50% of our work is done, right? So we know the entire area of the whole trapezium. Now what are we looking for again? Since we, as I said earlier on, we cannot find the area of the shaded portion, but we can find the area of the remaining part, right? So according to the question, it says that that is what a semicircle. So with a semicircle, we just need to go by the definitions of the semicircle. So how do you find the area of the semicircle? This is the area of the trapezium over there. So the area of semi, that's the semicircle. So the area of the semi, you should know the area of a circle, that is pi r square, right? So the semi means what? Half. So half of this one, so half of the circle. Is that okay? We already have a pi to be 22. This is the pi, right? So 22 on 7. Then the only thing that is missing here is just the r, which is the radius. So finding the radius here, this is the semicircle, right? So this is my semicircle. But according to the semicircle, if you redraw this thing clearly, you can see that. Sure. Let's say this is a circle, right? So this is going to be the semicircle. So taking this portion away here, then we have what a semicircle, and then everything here is 14 centimeters. Is that okay? Everything from here to here is that is what we call what a diameter, right? So that is what we call a diameter. We are not looking for the diameter, but rather we are looking for the radius. So the meaning of the radius is from the center to the circumference, or maybe to the edge of the circle, anywhere. Let's say from here to here. Is that okay? So finding here, you just need to divide this one into 2, right? So we know that that is all. The radius is going to be 14 on 2, and that's going to be 7 centimeters, right? So how simple that is going to be. So substituting that here, we have here to be equal to what? 1 on 2 multiplied by the 22 on what? On 7, and then everything multiplied by the r squared. That is what 7 squared. Is that okay? So very simple and straightforward. So I have what 7 squared centimeter. Remember to add the squared here because it's area. So we have 2 different areas that we are already looking for. So once we have these 2 areas, our work is done, right? So we almost have the work done. So what are we looking for now? We need to find the area. That's what the question is. I said find the remaining portion, the area of the remaining portion. So we have the entire trapezium here, and then we also have the values of the semicircle. So all that matters here is just to subtract the 2 and then find the values of the remaining portion. So yeah, you must always make sure that you answer the question. So that's the area of the remaining, right? So that's the remaining portion, or maybe region. So the remaining portion, that is going to be the entire area of the trapezium. That's a 207.8 centimeters square, and then minus the 77 here, which is the semicircle here. That's the 77 square centimeters. So what we are going to get is going to be what about the area of the remember the question says that to the nearest square centimeters, right? So in this result I have, that's the 1 squared centimeters. Is that okay? So this will be your the area of the remaining portion. So once again, don't forget to give us a thumbs up, subscribe to the channel if you are new here. Now let's have a look at more questions relating to the shaded portion. According to all the informations that we have on the question, that's we have the AB to be 24 centimeters, so the BC, that's 7 centimeters, and then O here is the center. Now the first question says that you should find the radius, right? So the radius, and then the second one says the area of the shaded portion. So area of the shaded portion. Now all that it means here is that with the radius, this is something that we are familiar with, but let's see how to do that. This is two shapes here, so any question that relates to a shaded portion, you must always identify the shapes that are involved. So we have the circle here and what, a triangle. Now with all the information that we have here to be what, a triangle. So one side of this, if you redraw, let's redraw the triangle here. So this is what we have. So with the numbers, this is where you have the 90 degrees. So the 90 degrees is out of B, right? So that is the B, and then we have the B to C. So here is going to be our C. Can you see? So B to C, that is all the 7 centimeters, and then B to A, right? So maybe A to B. So A is here, right? So A to B, and that is all 24 centimeters. So if I redraw the triangle like this, you can see everything clear. So what are we going to use to determine the radius? That is what the question says. So the radius, yeah, we all know that from here to this side is what we call the diameter. So once you have the diameter, we can easily determine the radius, that is from the center to the end of the circle, right? So let's find the diameter first. So how do you do that? So the tools that you are going to use to determine that, since this is a right angle triangle, right? So you can use the Pythagoras theory, right? So here, if you are represented here by A, any letter here of your own choice, we can see that. So this is the longest side of the triangle. We know how to do it. If you don't know how to do this, make sure that you comment in the comment section below. So we have the A square, that is going to be that's the hypotenuse, right? So maybe you can use H, just that you must define that. Is that okay? So A square, or someone will go forward the letters. So that is the length of AC squared. Is that okay? The same thing is going to be equal to the adjacent. So if you are here, we assume that you are here, so the adjacent is at the down here. So the adjacent, that is what, the 7 centimeters, right? So let's ignore the centimeters for some time. So that's going to be 7 squared plus the opposite, the one here, that's going to be 24 squared. Is that okay? So because the according to the definitions of the Pythagoras here, it says that the h, let's use the h as the hypotenuse. So the h square is equal to the adjacent square plus the opposite square. And this is what we are using. So you can even state that by the Pythagoras theorem. Okay, so once you have that, here we are going to we want to find the values of the AC, right? So from A to C here, that's going to 7 squared, that should be a 49 plus 24 squared. Do that calculation. So you should have your value to be equal to 625 by adding these two people, right? So remember there's a square here, so we're finding the square, the values of the AC rather. So that's the length of AB, that's good, taking the square root of both sides. So you have the square root of 625, right? So when I take square root here, this one will cancel this out, and then you have to take the square root of the other side as well. So taking the square root here, you have the values of this one to be, according to my calculation, I should have something that's going to be equal to 25, right? Is that okay? So everything here, that's from A to C. So according to the diagram here, A to C is going to be 25. But remember, the question says you find the radius. The radius is half of the diameter, right? So R is equal to diameter divided by 2. So the diameter is going to be the 25 divided by 2. So the answer is going to be 12.5 centimeters. So that is for what? The radius, right? So this value here is for the radius. Now let's see how to determine the second part. That says I should find the area for the shaded portion. So by the beginning of this video, we said something that once you're able to identify the area of the two figures or three figures that are, mostly it is two, right? So the two figures that are involved, you can subtract one from the other. So subtracting one from the other, this triangle is inside the circle. Okay, so if you find the area of the circle and then you find the area of the triangle, we can easily subtract the two and determine the area of the shaded portion. So now that we've answered the first part of the question, let's get to the second part that says that you should find the area of the shaded portion. So you need to find the area of the two shapes, and then when you are done, you subtract the one inside from the one outside, right? So here I don't know which one you want to go for. So if you want to go for the triangle, that's your own choice. So here solving for the area of the circle, right? So the area of a circle. So you should know definition. The definition that says per r squared. So we are giving part to be 22. So that's going to be 22 on what? On 7 multiplied by the radius, that is 12.5. That is what we had here. Is that okay from the first calculation? So everything squared. So what do you think will be the values of this calculation? So according to the calculation here, this is what I have. If you are having a different figure, don't hesitate to comment in the comment section. So I have 491.07 square meters. That is for the area of the whole circle, right? So the whole circle, we're being assumed that there is nothing inside. Now let's find the portion that this triangle is being taken. So that's also the area of the what? Triangle. So this is a symbol of a triangle what? A, B, and a C, right? So they have triangle A, B, and then C. So that is all. You should know the definitions of the area of a triangle. That says that 1 on 2, that is what? The base, and then multiply by what? By the height. Right? So remember the down here is going to be the base. Is that okay? So we draw this in such a way. The down here is going to be the base, and then here also the height is 24 centimeters. Is that okay? So the height is always straight perpendicular to the base, right? Okay, so perfect. So we have a 1 on 2, the base here, that is multiplied by the 7, and then multiply by the 24, right? So perfect. So the values of the area here is going to be, so here I have what? 84, right? So 84 squared centimeters. So these are the two values that we have. So these are the two shapes that are involved. So that's the triangle as well as the circle, right? So all that you are going to do is to find the difference between the two. That will determine what the area of the shaded portion, right? So that should be 491.07 minus 84, right? So anything that you have here, it should be what? The area of the shaded portion. So what is your value? Give me the values of this thing in the comment section below. That tells me that you are engaging, you are participating, right? Okay, this is how the next question looks like. With all the information is being given to us, all that they are asking us to find is the radius and as well as the area of the shade. This is similar to just the previous question that we've solved, but the trick here is that, or the only difference here is that, once again, just know the figures that you are dealing with, right? So the figures here according to the question, you have this one to be what? A semicircle, right? So the semicircle as well as what? A triangle. Now the secret here is that the Pythagoras theorem is applied to the right-angled, right? So right-angled triangle. Is that okay? If you don't know what a right angle is triangle, that is where one side of the triangle is exactly 90 degrees. So this is a symbol of that. You can only apply the Pythagoras theorem to what? A right angle triangle. Now you have to figure out whether the triangle inside the shape, in this case that is a semicircle, is a triangle, or is a rectangle triangle, or any other type of triangle. Here's the secret. Here, one thing you must know about this type of geometry is that from here to here is going to be what? The diameter. Do you agree? So that's the semicircle, the half of a circle. So from the end to the end here is going to be a diameter. So once the line moves from one end of the diameter, touches anywhere on the circumference, that is on the circle, right? So touches anywhere and then move straight to the other end here, it means that this side is going to be a 90-degree. That is the secret behind this type of shape. So that is something that you must know and understand properly. So once again, I say that if the line moves from one end of the diameter, in this case here, and then touches anywhere on the circle, so this is what I'm trying to say. If you have a circle, so here's a line that crosses through the center, that's the diameter. So if you move from this point, we don't care where you are going to touch on the circle. So once you hit the circle and then you move straight, that's the circumference, right? So you move straight to the other end of the diameter, right? So here is going to be formed at 90 degrees. Remember, once you touch here, we are not saying that the Lord didn't say that you should pass here. Have you see? If you pass here, you didn't reach the end of this thing. Yes, this side can never be 90 degrees. So that is one secret. So this should tell you that this triangle here is a right angle triangle. So you can proceed or using the same or the previous method here, that is finding the area of the semicircle, and then you find the area of this triangle and then subtract it to you find the area of the shaded portion. This question here may lose a little bit horrible, but all that matters here is to understand the trick and how to apply it. With the information that we have, you have the OR to be 5 centimeters, that is OR here, and then the area of the shaded portion, that is all 6 per square centimeters, right? So you want to calculate the length of a UR. So UR is just this small portion here. Okay, now we are told that the circle is concentric, so I don't know if that is correct, the pronunciation. So what it means here is that the two circles, or maybe the two shapes, are starting from or they have the same center. That is what the meaning of this word means, right? Okay, perfect. Now these are all that you have. So the trick here is to always master the idea of what knowing the shapes that you are dealing with, and then subtract the smaller one from the bigger one. Now even though this shape is a circle, the shading is not happening in the entire circle, right? So that is just happening at the portions of the circle. So the portion here is what we call a sector, right? So that is the sector. You consider if you know what a sector is, so that is just this part of a circle from here to here, that's going to be a sector. So the shading is happening only at the sector. So that is what you have to deal with. All right, so now that's you just have to identify the big sector and the smaller sector, and then subtract the two. That gives us the area of the shaded portion, which you have here to be 6 per squared centimeters. So okay, so we know the trick here is that to find the area of the shaded portion, you must subtract the bigger one from the smaller one. So here we have the area of the shaded portion to be 6 per, that's what 6 per squared centimeters, right? That's going to be the area of the bigger shape. So the bigger shape here is that's the sector. So the area of the bigger shape, that should be O sector, let's say UOT, gives me the bigger sector, right? UOT, that's going to be the big one, and the ROQ, that's going to be the small sector. Is that okay? So that's the area of sector what the bigger one, that's the UO, and let's say minus so let me show the area of sector. So this is the sector, so the smaller sector, that should be what ROK, right? So RO and then K. Is that okay? So that's very simple, because that is what the area, the shaded area from the previous questions that we solved. Is that okay? Yeah, perfect. So what is the area of a sector? That is going to be theta on what 360 degrees multiplied by what per r squared. You should know this definition. Is that okay? So that is the area of a sector. Now you have to find the radius of the sector UOR, as well as the radius of sector RO and then Q. Okay, so once you are able to identify that, we are free to go. So going back to the information given to us, we are told that OR here is 5 centimeters. So from here to here is going to be 5 centimeters. So that is something straightforward to tell us that the area of the small sector, so that is the small sector here, we are free to, we have all the information available, right? So what that matters here is going to be the radius, that is 5 centimeters, right? So the radius is 5 centimeters. So what about the theta? So dealing with the theta here, we can see that here is what, 90 degrees, right? So that is what this symbol here tells me that that's what 90 degrees. Is that okay? So if this is 90 degrees, I hope from here you can easily solve the rest of the equation. So that says that here the theta here is going to be 90 on what, 360, right? So 360 degrees multiplied by pi, that's 22 on 7, and then the radius of the bigger one, right? So the radius of the bigger one starts from what, O to what, to the U, right? So here you have 5 centimeters, so you have to add this small portion to that. So why don't you use a letter to represent? Maybe I'm gonna go for A for the small portion here. So that gives me the radius of the entire shape, that's the O to what, to the U, right? So that's giving you, it's going to be the radius. So multiply by the radius, that's 5 plus A, right? Everything squared. According to the definition here, right, we have the theta to be 90, and then we have the pi to be 22 on 7, and then R is the radius. So minus, so the second sector here, that's going to be the theta, the same 19 on what, 360 degrees multiplied by 22 on 7, and then multiply by the radius. So the radius here is going to be 5 square, right? So the radius of the smaller part. So that is the radius of the smaller here from here to here, that is the smaller sector. Now okay, so here that is all that you need to master here to find whatever you are looking for. Now what is the UR is the smaller letter here, right? From here to this portion is going to be our UR. So here, by solving this portion here, right, so you just, the only letter that's missing here is just the A. We know that everything is going to be 6 pi, everything is going to be equal to, because 6 pi here, that's the difference or the area of the shaded portion. Now someone may ask, how are you going to eliminate this pi here? So we know obviously that the values of the pi is 22 on 7 in some cases, but here according to the question we are not giving the values of the pi, either is 3.142 and so on and so forth, or 22 on 7. We are not giving the values of you may choose to leave it like that. Is that okay? So we cannot, if you are giving a pi to be 22 on 7, that is where you have to apply. Since we are not giving a pi, you may leave it as it is. So that's here we have a pi here according to the definition, and then here also to be what, a pi, right? So as it is, so that we can see a pi here. So that tells you that if you are divided all by pi, the pi will go away, right? So the pi will just vanish, so that you can easily focus on the calculation, right? So here you need to expand this thing here and then do your subtraction and addition. Give me the values of the A in the comment section below. That tells me that we are engaging. If you want us to break this thing down, make sure that you comment in the comment section below. If you get some value from this video, make sure that you subscribe to the channel for more content like this.